Oh, what's up? What's up? Anyone who's here already? If no one's here already, just what's up to the world. Um, I'm back. I haven't streamed in a bit. I've been really busy, but hopefully that busyness is essentially over now, at least for a bit. Hold on. Music's a little bit loud for me. Okay. Yeah, I was away for a bit. I had to spend a few days really focusing on prepping for my Amazon interviews, which I did, and I did them, and they're done. So all of my Amazon interviews, because I'm interviewing for a job in AWS, are behind me now, which is Pog. So I was spending a couple of days to focus on that, and then I spent a couple more days to unwind. There was definitely a day of drinking in there as well. But yeah, so hopefully I had a long pause. That should be gone now. I'm planning on streaming on a much more frequent cadence from here on out. Basically the same stuff. It'll be a lot of LeetCode, competitive programming type things. And at some point I'll probably get into some software development as well. But at least for now I'm going to stay on LeetCode. So, yeah, I updated my stream title, is that correct? I'm not going to do Clash of Code today. I'll be back for my next stream on Tuesday, and there'll definitely be Clash of Code in that. But yeah, no Clash of Code today. I'm just going to do some LeetCode problems, kind of chill a little bit. Probably nothing too difficult. And yeah, so one thing that I'll probably do at some point in the stream, if anyone's actually interested in it, like a user, or not a user, sorry, a viewer would have to say, hey, yeah, I'm interested, do this. And that would be, I did compete in the LeetCode contest on Saturday, the evening contest. So this was how I did, which I was quite happy with. I solved all 4, which doesn't always happen for me. I feel like Q4 of the last contest wasn't ridiculous. If you know how to do a topological sort, then you probably were able to do Q4, or if you haven't already, then you could do Q4 from last contest if you know how to do a topological sort. But yeah, I was happy with my score. So what's this? 1,300 out of 25,000. So it's like 94th percentile or so. So I was happy with that. I'm not entirely sure how that's going to affect my rank. I guess the rank changes come out, you know, several days later or whatever. So I'll be staying tuned to see if it goes up, goes down, or stays the same. No idea what that's going to do. It'll probably stay about the same, honestly. But yeah, so yeah, Q1. So I did them in order. I just went Q1 through Q4, and I solved Q1 in like 7 minutes, which, you know, compared to the top dog, who's literally pathetic dog, was slow. But you know, I'm happy with it. Q2, I had a bug. I had a wrong answer, but I got it in 16 minutes. Then Q3 took me about 30 minutes to get. And then I was happy with getting Q4 like within the hour, you know, because this is an 1.5 hour long contest. So for me, finishing the contest with 30 minutes to spare is good. You know, for some people, you finish the contest with 1 hour and 24 minutes to spare, that must be nice. But no, I finished it in one, like with 30 minutes to spare, which I was happy with. So yeah, I could go over my code for those at some point, but I'm not going to do it immediately. I think I'm just going to jump into some problems. So I don't know, I don't have any problems actually picked, so I was kind of just going to like look and find something, maybe start on something a little easier. I'm hoping for it to be a chill stream, so I'm probably not going to do anything crazy. But let's see, I do have a bookmarks folder of some problems that I'm planning to do, so let's see, what are these? Okay, this one seems like probably a decent one to just start with, because I got some subsequence problems here. Wiggle subsequence, which I don't know what it is, and longest common subsequence, which I do know what it is, but I don't remember the exact implementation, so hopefully I'll be able to figure it out. But yeah, I guess I'll just start with is subsequence, which is easy, according to LeetCode, so hopefully it'll be easy for me. Given two strings s and t, return true if s is a subsequence of t, or false otherwise. Fair enough. And so subsequence, obviously you can like skip letters, you can skip characters. It just has to be in there in the same order. So s is what you're checking to see if it's a subsequence, and t is the thing that you're checking against. So I think what can probably happen here is we can just iterate through t and keep a pointer to our current character in s that we're trying to match, and then as soon as we match it in t, we can increment the pointer in s forward one, and then if we get to the end of s, then we're good. It is a subsequence. Or if we get to the end of t but we haven't found everything in s, then it'll be false because it's not a subsequence. So let me see here. So let's just have int I equal 0, and int I is going to indicate the letter in s that we're trying to match. So that's just going to start off at 0, and then we can go through t, and we don't even need to do a. We can just do a for in loop. So we could do like for char c of t, and let's see if s sub I equals c, then we have a match. So we can do plus plus I. Yeah, that's it. And so now we can just check to see if I is at the end of s. So return. We need to have an extra check here, which is we can just do here like if I equals s dot length break, because we found it, so we can actually like exit the loop early once we find the full subsequence. And then what we return, I think we can just return this. So if we did end up breaking at some point, then we get down here, and then I equals the length, then we're going to return true. So this seems pretty straightforward. Use the example test cases. This is not a particularly complex algorithm, so I don't know quite what more I should check. B. I don't even know, dude. What about like Y in Y? Something like that. I mean, the algorithm seems sound, unless I'm missing something really dumb. So I'm just gonna submit. Okay. Nice. So that's a correct solution to that one. It was accepted. It runs really fast, which is nice. My Python solution from 2 years ago. I'm just curious to see what that was. It was probably the same thing, right? Oh, I did, yeah, like a two-pointer approach, but I honestly like my code from this go through more. Yeah. Okay. All right, so that's is subsequence. Just get a quick one out of the way. Do I want to go straight to this, or should I do something else in between? Let's take a look at some problems. I don't know. I've still got my LeetCode Premium, which I might actually be canceling now because I finished my Amazon interviews. But oh, here we go. ByteDance. That's TikTok, right? I interviewed with them as well. I actually haven't finished my interview process with them. I have one more interview, which is on Thursday. Let's see what ByteDance is asking. Let's see. Let's sort by difficulty. Oh wow, ByteDance asks this? They actually ask first missing positive? Oh, it's a really low frequency. Hold on. Okay, let's do this. Okay, so this is interesting. So apparently the highest frequency ByteDance problem is case-similar strings, which is hard. Maybe I'll take a look at that. It's, according to LeetCode, that's a hard question. Strings S1 and S2 are case similar for some non-negative integer k if we can swap the positions of two letters in S1 exactly k times so that the resulting string equals S2. Given two anagrams, okay, so you're already told that they're anagrams, you have to return the smallest k. Oh, that's interesting. That's interesting. So what's the worst case? If you have to, like, you can always turn S1 into S2 with exactly n swaps, right? Where, so like n is just the size. So then it's actually more about improving that. Also, it is interesting to note how similar this idea is to bubble sorting. In the bubble sort algorithm, which is a really slow sorting algorithm, you just swap two characters that are not, in the correct position relative to each other. But what we need to do though is ideally every swap we do, we're moving one of the two characters into the right position. Oh, is this a graph theory problem? Like, is this a shortest path? That's what I'm wondering. Because, like, you could swap a letter. You could do like a naive thing, right? And you could be like, okay, so let's take a look at this example 2. Like, you're trying to turn ABC into BCA using as few swaps as possible. So, for example, we know that the A needs to move to the end. So we could greedily, without thinking about anything else, just swap the A with the C. And now the A is in the right position. But this is a kind of a simple case, because then the next thing, the reason the output is 2 is because then the next thing you do is you swap the first 2, which will put the B and the C in the right place. But it might actually not be optimal to just take a letter and swap it to the correct position greedily. It might be better to swap something else first and then do that. I mean, eventually you're gonna have to swap all the letters into the right position, but I don't think this is a greedy. What's the max size? So the max size is 20, which is not very long. Oh, there's some interesting limits here too. S1 and S2 only contain letters from that set, A through F. So they're... So how many permutations are there? It would be... How many... So the number of possible strings is going to be 6 to the 20th power. What is that? What is 6 to the 20th power? Oh, that's a shitload. That's a shitload. So you have to do your search, you know, in an intelligent way. So this does still feel like a shortest path, but is this just breadth first search is not going to work for this, right? That's too slow. So basically for a breadth first search, you would take the current string as your starting node, and you would just swap every possible pair of characters in it, and those would be your neighbors. That number of swaps is n squared. Or I guess it would probably be exactly n times n plus 1 over 2. Let's see what the related topics is. Wait, do I want to reveal that? Because that'll give me a good clue on what to do. Like, I'm thinking that this is... I'm definitely thinking that this is the shortest path. Could we do better than breadth first search though? Like, what about Dijkstra's? For Dijkstra's, you would need to know the cost of a swap. No, that doesn't work because the cost of a swap is just 1. Right? You do any swap and it just adds 1 to your K. Is breadth first search actually going to be too slow? So what's 20 squared is 400. So basically each iteration of the BFS would give you 400 neighbors to check. And then what would be the worst case for how many iterations there are of the BFS loop? Really bad, right? That'd be a shitload. So I don't think this is BFS. So let's think about it slightly differently. So we know that we know what the final positions of all the letters are. The question is, what's the optimal swaps to get it there. So like A could go to the end with one swap. In this case, for example, 2 it does. But A could also get to the end using 2 swaps. It could first go to the middle position, and then it could go to the, oh, and that actually would work as well. A swaps with B, so you get BAC, and then A swaps with C and you get BCA. But that's probably not always. Let's make it one longer. So what about ABCD needs to become DCBA? So you could swap the A to the end immediately, and that would put the D at the beginning, which is what you want. And then you could swap the ones in the middle. So this would actually also be 2. What about A, B, C, D, E? It's probably, I shouldn't be thinking about this in like terms of like always reversing it. So what if I need to do like B, C, A, D, something like this? What would the expected output be for that? So for this one, we can see that the A needs to go where the C is. So in this one, the first 3 characters, A, B, C, need to become BCA, which is this example. So that's actually a sub-problem, which indicates like maybe this is some kind of dynamic programming, but what if it was this instead? So in this case, A needs to go to position 4. So we could swap it with the D to put it straight there. That puts the D at the beginning. So then the D needs to swap to come to the end. Whereas we could swap the D and the E first. Okay, let's look at the related topics. String breadth first search. Okay, so that's what I said. Is that not going to be too slow? Maybe you need to do breadth first search like smartly. Like you're not looking at every single neighbor maybe? I don't think that a simple BFS is going to be fast enough. Simple BFS being, you know, the input string S1. We call these A and B. That's what I usually like to do in problems like this. So string A. That's our start node for the BFS. And then what we can do is all the neighbors of this would just be the results of swapping each character with every other possible character. So basically taking all of the unique pairs in here and swapping them, and then putting those onto the BFS queue. Do we need to consider all neighbors though? So is there a case where we do a swap and something doesn't end up in the right position? Right? Like every single swap we do, one of the letters is ending in its final resting place, so that it does not need to be swapped again. Yeah, that makes sense. No, that's correct. That's correct, because the worst case scenario is that you have to do n swaps, where you're just swapping every character to its final position. So in order to do better than n, you can't possibly need to do a swap where one of the two characters doesn't end up in its final position. Okay, yeah, okay. I think I'm going to try to code that up. That seems like it would speed it up a lot. That would significantly reduce the number of neighbors that the BFS needs to look at. So the question is how to represent this. Let's do this one in Python. So let me copy these comments and do it in Python. How do you do a queue in Python? Do I have to do double-ended queue? Is that the Python equivalent? So, oh no, it just has a queue. It just has a queue where you can put, whoa, multi-producer, multi-consumer queues. Oh, this is for like, no, this is not what I meant. This is for like multi-threading. How do you do a queue in Python? Yeah, but isn't that going to be slow? Okay, yeah, so this is what I need. I'm pretty sure I need collections.deck, and then I can do append and pop left. Yeah, that's better. So I'll use collections.deck. Okay, so we got collections.deck. Let's call this AB. Don't know if I'm gonna need it, but n is just gonna be the length of A. And now Q is gonna be a deck. Okay, and then now while what's the semantics for it? I mean, I think len will just work. While len of q exists, so first I need to append the start onto it. So q dot append a, and no, I need to append also the distance. So I'll append, it'll be tuples, I think. So I can just do a and 0. And then I can do x equals q dot pop left. No, I could do x and then d for distance. And then if x equals b. Oh, and I also need a set for what I've seen. I'll add that in a second. Then it's just return d right here. So I need like scene equals set let's see, and then I'll put it in scene here. Scene dot add, is that how you do it in Python? Scene dot add a. Okay, so the next thing is yeah, we don't need to revisit nodes, because it would, if we revisit a node, that means we're getting there from a longer path, so we just don't need to consider it again. So the next thing is to consider the neighbors. So how many neighbors are there? There's n neighbors, because we're going to try to put every node in its final position. Pardon me. hold on. And there's another element, which is you could have duplicates, right? You could have A, B, B, and like that needs to become B, A, like. So in that case, there's already an A in the right position here, so we don't have to do anything. So let's just do for I C in enumerate X. And we're going to try to put C in the correct position. So whatever the index of C is in B, so C could already be in the correct position. If it's not, then there's definitely an index that it can move to, right? So first of all, if B sub I is C, then we're good. It's already in the right position. We don't have to do anything. So if we get past that if statement, that means that C does need to move. So we have to find out where to move it to. So basically, it's going to be any index in B that is a C, where there's not already a C at that same position in X. This is all, because the length is 20, this is all basically, you can think of it as constant time work. Okay, so B sub I is not C if we get to this line 19. So that means we can find at least one index where C can move to. So we need to know the indices of C in B. Let's call that like B I don't know, B in index or something. How do we get? Okay, so it's going to be J for J, F in enumerate B if F equals C. So that's going to get us all the indices in B where a C needs to be. If F equal, if F equals C and X sub J is not equal to C. I think that'll work. And then there's guaranteed to be at least one of those, and the one we'll use is just B index of well, we can use all of them. Those are all valid neighbors that we can try. So for BI in B index, we're gonna add on to the queue. So first we're gonna generate the next X. We'll just call it Y equals X, and then Y sub BI equals C, but first Y sub I equals B sub BI. Is that right? So we're gonna take what's at the, oh no, X. Whatever's at X. Oh, we also don't want to move we don't want to swap something in X that's already in the right position. And X sub j is not equal to, no. Oh, this is getting confusing now. I should have named my variables better. So we're trying to find the indices in B that C can move to. So basically, we go through B. We've got J and F. Yeah, so if it's a C, then we move there, but also oh, no. Okay. Yeah, I think I just convinced myself that we don't need this last if statement. So I just need to make sure this is right. So y is going to be what we add to the queue. So we just copy x in. Then y sub I becomes whatever is at x at the B index, right? Oh, wait, no. This is not right, because this is what we're copying over. This is what we're like, where we're coming from in the swap. So what's at xbi could already be in the right position. Yeah. So it is. I do need this. And x sub j is not equal to b sub j, I think. So we copy it in. Then y bi equals c. Okay, I think this is right. And then if not seen dot has, how do you, oh, it's just y not in seen, then seen dot might just be append here, but y, and then q dot append the tuple y and d plus 1. It's probably not quite right. If we get to the bottom of the while loop, well, yeah, we won't get to the bottom of the while loop because since they're anagrams, this code is guaranteed to eventually find the solution if it's fast enough. Run. Oh, string doesn't support item assignment, so we got to turn it into lists. So we can just do A equals list A, B equals list B. And then when we return, yeah, we're just returning D. Unhashable type list. Oh, does it need to be tuple? Shit. Oh. Yeah, we'll just do, scene will just be the string version. Starting to wonder if this is actually going to work. Okay, yeah, so this needs to be an empty string dot. if yeah, we'll do it this way, I think. Okay, I think we'll just call this key. Okay, example test cases. Okay, what about my test cases? So we're passing some of the sample test cases. Let me add some extra test cases in here. Yeah, fuck it, let's do this one as well. It's encouraging that we passed the samples though. I don't want to get my hopes up. What about just A and A and A and A. Okay, so we're passing those test cases. And okay, this feels good. Should I just submit this? Let's make like, how do I make a good test case? A, B, C, D, E, F, G. A, B, C, D, E, F, G. So we'll have that, and then let's like rotate this. So I'll put the ABC at the end here. Oh. No G's allowed. So that one's 6. Okay. So we're getting correct output for that. Oh, hey, baby in the chat. What's up? Welcome back. And Shal Gaming, I see you there too. Glad you're both hanging out. I was gone for a while. I don't know if you noticed. If not, I was gone for a while. I was gone for like a week because I had to focus on finishing prep for my my Amazon interviews. But my Amazon interviews are done now, so. Oh, you use your emails for that. Interesting. That's cool. Yeah. Well, the good news is my like week of just like serious like head in the books interview prep is done. So the streams should become much more regular now. I don't know if I was hired. So I think I did good enough to get hired, but I won't find out until I think tomorrow at the earliest, but it could be someday this coming week. So I've really got my fingers crossed for good news from them. It would be super pog if they decided to hire me. But if they don't, I have some other interviews that I'm less stressed about. Like I still have an interview with TikTok coming up. I got a couple of other companies that I have phone calls scheduled with, which I'll happily cancel the phone calls if I get an offer from Amazon, but like just in case, you know. TikTok, they actually pay pretty well. I was looking at their salaries, and like the team that I would be joining uses a tech stack that I'm familiar with, so I actually wouldn't mind working there, and the people seemed pretty cool. So Shalgame, how do I know it's a cube problem? So I spent a while thinking about it, like when I first opened the problem up. And also the reason I opened this problem up is because it's listed as a ByteDance problem on LeetCode, ByteDance being, you know, like the parent company of TikTok or whatever. So I thought, why not look at something that TikTok asks? But this to me is a breadth first search. And the reason is because at any point, when you're like when you're, you know, finding the shortest path from the start to the end, you can swap elements of the string with other elements, and those swaps are like the neighbors. So the start node for the BFS is your starting string, which I have renamed in my code to be A. Also, my variable names are just dreadful here. I apologize for that. I should have done much better with that. But yeah, so I just start off by putting A in the queue, and then after that it's kind of a standard BFS where I have this logic here for calculating which neighbors are worth looking at. And I'm not looking at every possible neighbor, because I discovered while I was thinking about it that you only actually need to consider neighbors where the swap that you do to go to the neighbor moves a character into the right place. You're never, it's never optimal to do any swap where at least one letter is not ending in the right place. And baby in the chat, you're right. This is similar to bubble sort. This is kind of a similar concept where you're just doing swaps to get something in a different order. In the case of this problem, the order is whatever they specify in S2. But yeah, thanks. I hope I get hired too. I hope I get hired too. So I feel pretty good about this. I'm going to submit it. It might be too slow. This is, oh, time limit exceeded. Time limit exceeded. So I got time limit exceeded on this. Let's focus in on that test case. So basically, I think the way that I need to get around time limit exceeded is by not looking at neighbors that I don't need to look at, which I was already trying to do, but apparently I should be doing that even more. Let me get this test case. Q would have never popped in my mind for this question. I would probably think of greedy or some math solution. Well, Shell Gaming, I didn't get it right, so Q might not be the best approach. Although I did take a peek at the related topics down here, and it does say breadth first search. So I had said breadth first search before I opened this up, but then when I opened it up, I was like, oh, okay. I guess it is a breadth first search. So for that reason, I think it probably is a Q. But a math solution, yeah, that's interesting too, like trying to count the number of letters that are like swapped or something like that. But yeah, it's definitely not greedy. It's definitely not greedy. I thought about that for a bit. Maybe in the chat, you're practicing C++, it's so hard, stuck on trying to optimize your to-sum code. Oh, to-sum? Well, yeah, I know to-sum. Have you try to think about how you can use maybe a hash table to speed that up. There's so the solution you have is probably the n squared solution. Then there's like a middle solution, which is actually the hardest one to implement, which is binary search in n log n time. And then if you figure out how you can use a hash set, then it brings you down to linear time for that one. Oh, also, I competed in the LeetCode contest on Saturday, and this is how I did. So I don't know if either of you decided to look at that. Also, the contain duplicate one, my solution is inserting numbers into a vector and seeing if the target is in there. Yeah, okay. So instead of using a vector, try using a unordered set. Because with a vector, if you're like looking something up in a vector, unless it's like ordered, you're looking it up in linear time. Threesome is even better. I don't know if I know threesome. Oh, I do know threesome. I solved it in 2020. Looks like it took me a bunch of tries, though. I might have to come back and look at that at some point. Okay. Oh, I see. Shell Gaming. Yeah. I thought that Q4 was... I I thought it was easier than usual, but that might just be because I kind of already had topo sort in my mind. Like not for the contest, but I saw the problem and I recognized it was top sort, and I knew that that's what I needed to do. So these were my times. I got 7 minutes, 16 minutes, like 30 minutes, and then 52 minutes, which I was happy with. Like I'm not upset at all with this rank, 1300 out of 25,000. But then it kind of like blows my mind to look at like the top players, the top contestants who get like everything solved in 6 minutes. Sheesh. Anyway. But getting 3 is good though. Like I've had plenty of contests on LeetCode where I just get 3. I still get 3 often. Sometimes the 4th one is just, you know, requires a technique that I don't know, so I'm only able to get 3. Let's take a look. So time limit exceeded. I don't know why I hit submit. We already know that it's time limit exceeded. There's got to be some kind of optimization I can do here, because I'm looking at too many neighbors apparently. This isn't even the largest test case. The strings can go up to length 20. And this is like, what, 16 or something? Oh, the first guy is multiple guys on one account? Oh, that's dumb. But they submit it the way that it looks feasible, you know? 51 seconds for the first one, 2 minutes for the next one, 4 minutes for the next one. Like if you're a god, I could actually see these times being like possible, you know. But yeah, that's one way to cheat, I suppose. Just have multiple people coding. Numbers got what, 3rd place? Still really good. He did them in reverse order. Oh wait, he did something interesting. How did he get Q4 10 seconds after he got Q3? He must have been working on them at the same time. It looks like he might have been working on like all of them sort of at the same time because of his times. But anyway, welcome back, welcome back. I don't know what's wrong with this or how to make it. Well, I know what's wrong with it. It's too slow. I don't know why it's too slow or how to make it faster just yet. So I wonder if this is not right. So this logic right here, B index, this line of code, this is trying to find the indices that the current thing could swap to. So basically I'm popping off the queue, and then I'm going through all of the characters in X, and like if it's already in the right position, then I don't do anything. So that's what these 2 lines do. If it's not in the right position, that means there's at least one index it could swap to. So what my logic is trying to do is figure out all the positions it could swap to. So that's what this B index is. It ends up being an array of indices that I could swap to from the current position. Ooh, trivia question. I'm down. I'm down. Let's see. What program do I use to draw solutions? So I've been thinking about trying something different, but as of right now, I use a free website called Excalidraw, excalidraw.com. Oh, this was actually from one of my Amazon interviews. I didn't sign an NDA though, so it probably doesn't matter if I show that. So it's Excalidraw. And yeah, they have a lot of, I mean, you can just like draw, which is nice. But the other thing you can do is they have like shapes that you can use too. So I could do like rectangles. I like the style of it. Like if you try to do a background color, it kind of looks like it's colored in with like a pencil, which is nice. You can put like a circle, and then you can connect them with arrows. So it's got some of the like nice stuff like that, but I don't really use that. I usually just like draw stuff like this. It's faster for me. But yeah, it's called excaladraw.com. Trivia question. Let's see. Okay, here's the trivia question. What programming language did Bjarne Strusup invent? That's the trivia question. Bjarne Strusup. What programming language did he invent? It's not C. It's that's close though. That's close. Yeah, it's C++. It is C++. Very nice, I'm baby in the chat. I have another trivia question for C, so remember the answer for C, and then you'll get it next time. Hey, I'm the baby in the chat. You get to be VIP again. Hey, don't say that. No one's a loser. He was really close though. I mean, Bjarne definitely like took C from where it was and added, you know, a bunch of stuff. So it wasn't a completely original language, but he was the person to, you know, add everything on top of C that turned it into C++. C++ originated from C. Yeah, that's correct. That's correct. Someone else invented C though, and then Bjarne Strusup, he took C and augmented it. He like added classes and inheritance and a bunch of other stuff, and then that made it into C++. Was that a poorly phrased question? I don't think it was. No, I mean, it definitely wasn't, because Bjarne Strusup didn't invent C. C was already around. He took C and added to it. Okay, let's see. I don't know how to make this faster. So I go through all the indices in B, and if F is C, yeah, that's what we want. So we want it to be, this basically says it needs to be a spot that the current character, which is C, moves to. X sub j needs to be not C. Oh, we already know that X sub j is not C, because we checked that here. Oh, no, we don't. No, we don't. And I don't know. Let's this is listed as a hard problem. I don't know if I'm going to be able to figure it out. Write in chat often. I mean, you don't have to write any more than you already do to do that. You're a very active chatter, which is an appreciated quality. I'm not saying that to complain. Let's take a look here at what, maybe we can just get like some insight in how to change the code. The trick is that you need to swap the first A, B, B, A pair every round instead of other pairs like C, D, D, C. Wait, is that not what I'm doing? What? Look, he's just doing a BFS. Why is mine not fast enough? The trick is that you just need to swap the first AB to BA pair every round instead of other. Oh. Wait. Okay. So if that's true, then all I need to do is Clash of Code battles tonight. I actually wasn't planning on it because I started the stream late, and I just kind of wanted to do some LeetCode problems. But I won't be here tomorrow, but I will definitely be streaming again on Monday, probably longer than I will tonight. And on Monday, I'll do Clash of Code at the beginning of the stream. Yeah, sorry, but that gives you time to practice, though. You know, you can go in Clash of Code anytime. and do some clashes, and then we can do it together on Tuesday, because I won't be here tomorrow. Let's add a break statement here and see what happens. Where's my, hold on, where's that test case that I failed? I wrote it down, it's over here. No, it's still too slow. I didn't sign an NDA. No, I didn't. No, I don't feel bad about talking about the interviews. They didn't ask me to sign an NDA. So, one of the questions was hold on, let me come back to that. I'll definitely talk about the Amazon interviews in a minute. Why is this not working? Logical thinking with clear Java code. Okay, let's just read through this. The essence of the problem is minimum number of swaps, right? It's the shortest path problem, so we can utilize BFS. Yeah, we're doing that. The graph we build sets all possible strings that can be swapped from A as nodes, and an edge exists if one string can be transformed into the other by a swap. So starting at A and ending at B. So that's the BFS idea. However, that will cause TLE, right? We set all possible strings that can be formed by swapping the positions of two letters in A one time as neighbors of A. However, only those can make A and B differ less are meaningful neighbors. That is, A prime of I is not equal to BI, but... Okay. Yeah, this is kind of what I was trying to do in my code. I was trying to only go through the meaningful neighbors. I don't like how they defined it, though. A prime of I is not equal to B of I, but A prime of J equals B of J. Oh, yeah. Yeah, this is what I'm doing. So this is saying that by doing the swap, one of the two characters is moving to the right place. But it is okay for the other one to move to the right place too. How come this gives me time limit exceeded? Let's see. If find array begin, array end. Oh. Hold on a minute. Let me... Okay, I'm going to take a brief tangent to look at this code. Oh wait, this is not the right problem. So, return true if any value appears at least twice in the array. Got it. So, I think it might be how you're doing find here. What if you were to do my r.count nums I. Yeah, that's one of the weird things about C++ is apparently the way you were using that find function, it's not doing a proper like hash table lookup. So my only assumption is that whenever you use this find call with myArray begin, myArray end, and the number you're looking for, I feel like that's doing a linear search. It's not doing like a hash lookup. So one of the things, one of the things you can do with an unordered set is you can count the number of occurrences of a certain thing in it. So this is just saying, it's saying myArray, count the number of nums I you have in there. And if that's greater than 0, then this will be true, and then it will return true. However, I do think that you could have done... I think you could have used find, but I think you have to use the find that lives on the unordered set. I think you have to do find like this. Is not equal to my array.end. Does that work as well? Whoops. So what about that? Yeah, that works as well. Yeah, so I feel bad, my baby in the chat. That was just a weird C++ thing. You definitely had the right idea. The problem was that the version of find you were using was not doing like the fast version of the lookup. In order to do the fast version of the lookup, you have to do array.find. Or, as I showed you before, you can do array.count. Stu Squared, what's up? Welcome to the chat. Welcome to the stream. We're just doing some LeetCode problems. I was looking at this problem, and I owe Shal Gaming a discussion of my Amazon interview process. I'm also going to have to try to recollect what the problems were. So I had a coding challenge in my phone screen, and then for my main interviews, which were 5 interviews, I had 3. Because I had one interview that was all behavioral, and I had one interview that was system design. So out of the 5 interviews, 3 of them involved coding. Smart, handsome. That's kind of you. Still not quite sure that I understand how I'm supposed to find the meaningful neighbors. We set all possible strings that can be formed by swapping the positions of 2 letters in A prime one time as neighbors of A prime. However, only those that can make A and B differ less are meaningful. So they need to differ less. That means that if A prime sub I is not equal to B sub I, but A prime sub J equals B sub I. Yeah, okay. I thought that's what I was doing in my code. I thought I was doing that here, but maybe I'm not. And I gotta try to figure out why. So Shal Gaming, one of my interviews with Amazon was a depth first search with backtracking. It was basically, there's probably a similar problem on LeetCode, honestly, but it was, you're trying to get from one word to another word, which is kind of what this problem is asking. But so basically, you start off with like dad, and you want to get to dog, right? So this would be like string A, and this would be string B. So you want to get from A to B. At each step, you want to figure out like the minimum number of steps to get from dad to dog. At each step, I was allowed to change one letter to be any other letter. So, for example, I could have done like dab, like that. But one of the requirements was that each intermediate step needed to be a real word as well. And so like, you know, dot, 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 and then eventually you get to dog. So that was one of them. And in order to determine if a word is a real word, he basically said there's a function like bool is word. Like that. And he didn't implement it. He just said like, call this function wherever you're deciding if a word is a real word. So that was one of the problems. Honestly, like the coding sections of my interviews were not the hard part. It was all the behavioral stuff and leadership principles and all that. And like even the system design part was like, I felt like I did really well on it. Hopefully I did well enough on the leadership principles and the rest of the like all the behavioral stuff to get hired. Word ladder. Yeah, exactly. This is it. Companies. Amazon 53 times in the last 6 months. I should probably tell them that I was asked this problem too, right? Whoops. Well, let's make it 54. I don't mind contributing back to... hold on, get me back to that problem, please. Contributing back to LeetCode since it helped me out. Seen this question? Yes. Amazon. Last week. On-site interview. There we go. Does that show up right away if I refresh the page? Hey, Gigantic Bucket, what's up? What's up? Welcome back in. Yeah, the interviews I think went well. Like, I've been telling myself and I've been telling everybody who asks that I'm trying not to get my hopes up. You know? I'd rather get excited after I get an offer than get excited before and then be disappointed. So I'm hoping for good news next week, possibly as early as Monday. But it could be not Monday. Like I might not find out till Tuesday or Wednesday or something like that. But yeah, crossing my fingers for good news. And Gigantic Bucket, that's why I was MIA for a bit. I felt like I should just take some days to just focus purely on preparing for that. But now that that's out of the way, I plan on streaming more frequently. Oh, Shal Gaming, I worked for Google. I worked there for 1.5 years. That was my previous job that I had. Yeah, it is nice to come away feeling happy. I'll tell you one thing. I'm going to feel equally sad as I am happy now if I don't get offered a job. But I'm trying not to think too hard about that, and I'll just deal with it if it happens. And hopefully it won't happen. But yeah, so as you pointed out, Shal Gaming, that was this one. What was my other coding problem? What was my other coding problem? Well, one of them was a weird problem. It was not really like an algorithm problem. It was a data modeling problem. Basically, it was kind of open-ended. The interviewer came in and said, I want you to like design an in-memory model for managing comments, where like comments can have sub-comments and reactions and likes and stuff like that. And so I had to go through that, and then after I got the model in place, he wanted to know about how I would sort it. Like if, for example, like I wanted to sort in a Reddit style by like number of upvotes and stuff like that, or he wanted to know like how can you sort by number of reactions, but then like within that, the time that the comment was written and stuff. I feel like I did decently on that too. And then what was the other algorithm problem? Oh yeah, the other algorithm problem was very similar to an LRU cache, except it wasn't LRU. It was it had a different eviction policy. So it was create an in-memory cache which has a maximum capacity, and once the capacity is reached, you should evict the largest thing in the cache. And so my solution to that actually was a very similar class to how I would implement LRU cache, except I used a priority queue data structure within it to keep track of basically keep track of the largest cache member at any time. So those were the 3 questions. And then my system design question was kind of like implement Twitter. And this is actually exactly what I did. This was my implementation of Twitter that I had time to do. Because what was interesting about these interviews is like they'd spend 20 to 25 minutes asking leadership principle questions. And then there was only like 20-25 minutes left for an actual, a technical question. So this was my attempt at building Twitter, with like between 20 and 25 minutes left in an interview. So I could talk more about that if anyone was interested, but like because the position that I'm interviewing for, it was like a senior position, although depending on how I did, I could get down leveled from Amazon calls it L6. I could get a job offer for L5, but because I was actually interviewing for L6, they weighted the interviews very heavily on leadership principles, which meant I had less time to do actual coding or system design at the end. And they did not make me run code, but I did like step through my code like verbally with examples and stuff like that. I think I'm done with this one. I don't know why I'm still looking at this. Let's look at something else. I might come back to that another time. Wiggle subsequence. I don't know if I'm going to do this, but let me just read what it's about. A wiggle sequence is a sequence where the differences between successive numbers strictly alternate between positive and negative. The first difference, if one exists, may be either positive or negative. A sequence with one element and a sequence with 2 non-equal elements are trivially wiggle sequences. Makes sense? So for example, 174925 is a wiggle sequence because the difference is 6, -3, 5, -7, 3 alternate between positive and negative. In contrast, 14725 is not, because you have increasing here with the 147. So your sequence, there can't be any, like in your subsequence, you can't have a subarray greater than 2 in length that's strictly increasing or decreasing. Let's see. So what do they actually want? A subsequence is obtained by deleting some elements from the original sequence, leaving the remaining elements in their original order, right? Given an integer array nums, return the length of the longest wiggle sequence. So is it possible for numbers to be the same? Can there be zeros in the differences? Okay, so they say that with the wiggle sequence, the differences have to be strictly alternating between positive and negative. So you can't have a difference of 0, is my assumption from that. Can you solve it in linear time? Well, that's a follow-up. Let's try to solve it first. Apparently that can be solved in linear time. So this problem came from the LeetCode dynamic programming study plan. So my assumption is that it can be solved in a reasonable runtime using dynamic programming. For the cache thing, did you get into priority queue implementation versus heaps, etc.? I didn't get too much into the implementation. I did say that it was a heap. However, when I first started solving the problem, I wasn't using a priority queue. I started solving it with a binary tree. So in C++, I was using C++, and so I was using a map. And then I came up against a problem where, basically I realized I didn't need a map because I didn't need to look things up by the key. I just needed like an ordering. So I switched over to a priority queue. And at the end of the interviewer told me that that's what he was looking for. So that was a really good sign. Looked easy until I saw example 2. Bill the Gray, what's up? Welcome to the chat. Oh, Gigantic Bucket, are you looking into starting some interview processes as well? I have a lot of, well, not a lot, but I have like resources that I usually point to for people who are preparing. One of the big ones is Algo Expert. Bill the Gray, aloha. Does that mean you're in Hawaii, or is that your usual way of greeting people? Either way, I'm just curious. But aloha right back at ya. So I'm not going to worry about the ON runtime right now. I almost wish I didn't read this part because I'm going to try to solve this probably in n squared time using dynamic programming. Oh, well, what's up? That's cool that you're in Hawaii. I've never been there, but it is a bucket list destination. Not interviewing anytime soon. Fair enough. You're looking for remote work only. Well, in the current industry, you know, the current job market, that's very reasonable. There's a lot of companies that are completely fine with that. I wish you the best of luck. Okay, so I'm pretty sure this is going to be... I think it's going to be two-dimensional DP. Oh no, is it? Because I solved a similar-ish problem the other day. It was actually off-stream. I solved longest increasing subsequence. And this is similar. It's not the same, but this is similar. And so I'm wondering if, because it's similar, if it can be solved in a similar way. So let's just start with this for now. So the idea behind this DP is DP of I is going to be length of longest wiggle subsequence ending at I. Yeah, this is gonna work. I'm pretty sure if I do it this way, it'll solve it in n squared time, which is probably good enough to pass all the test cases. Yeah, it is. So if you look, numbers.length is 1000, so n squared would be 1,000,000, which is completely fine. N cubed would not work. And then apparently there's an ON solution that I'm probably not gonna worry about. I have Amazon recruiters reaching out almost every other week, so I will probably attempt the interview in 2 to 3 months. Oh, hell yeah. Yeah, I mean, I like how you're trying to, I like how you're thinking like that far ahead. Give yourself the time to prep. You know, you'll definitely, you'll be able to do much better if you spend that time like preparing properly. You can do easies, 30 to 40% mediums, and maybe 5% hard. Need to get at 50% hard. I don't even know if I can do 50% hard, honestly. Like, you just saw me quit a hard problem. Although, yeah, I still kind of feel bad that I quit that problem because I was close to a solution, but I didn't feel like figuring out what was wrong with my code. Bill, you said, I wish so much emphasis wasn't placed on algos. I'm definitely more of an architecture type. Gotcha. I've been considering move to DevOps. Yeah, I mean, that'd be a good place to go. DevOps is really, DevOps is actually really high in demand. I don't remember, oh, I do remember where I saw it. So on Coding Game, which is the website where Clash of Code is, I was reading through this, there's like an annual report on like hiring trends and like interviewing trends. I wonder if they still have it. Coding Game, technical recruiting report or something like that. Yeah, this is it. So I'm not gonna go through this right now, but but I was reading through this recently. It was actually really interesting. And somewhere in here, it talks about like what skills are the highest in demand and the hardest to find by recruiters, and DevOps was up there. Let's see. Here we go. So this yellow bar is like recruiters struggling to recruit. And the blue bar is developers' current positions. So, I mean, it's important to keep in mind that the audience of this survey is going to like impact, you know, these results. I don't know how many DevOps people actually took the survey, but according to, you know, their results, DevOps is difficult to find on the market. So recruiters are looking for DevOps and finding it difficult to find people. So that's worth keeping in mind. I'm initializing all of this to 1. Well, technically they're actually all 2. Oh, no, they're not. Yeah, I'm not sure. I'm not sure what the interview prep is. Like, honestly, I know very little about the kind of work they do. So, yeah. So for this one, I think that this approach is going to work. So I'm going to start at the end and iterate backwards. And at every single position, I'm trying to store in the DP for every I. So this is going to be like I equals n minus 1. I is greater than or equal to 0, minus I. So I'm going to store dp of I, and it's going to be n squared because I'm going to have to do another loop within here to find it. But then I have to update the answer as I go. So like answer, so the answer is going to be at least 1. There's like at least 1 wiggle subsequence, a wiggle subsequence of length 1. So down here we'll return the answer. And after we calculate dp of I in this for loop, the last thing we'll do is answer is going to be the max of answer and dp of I. So now the interesting part. So I want to iterate from, basically I want to iterate from I plus 1 to the end. So I can actually start this outer for loop at n minus 2. And then for int j equals I plus 1, j is less than n plus j. So I'm going to look ahead in the DP array at positions I've already calculated. And when I look ahead, I can look at the corresponding number in the input array. And if it like qualifies as forming, you know, a wiggle subsequence with the current number. So if I take the difference and it's positive or negative, I won't have to add additional logic because those have to alternate. Then I'll use that. And I've been studying for Cloud Plus, Linux Plus, and I imagine knowledge around end-to-end tests and build automation. Yeah. That all sounds perfect. That sounds like all the right stuff to be doing. Unfortunately, I don't know a lot about those topics, but yeah, that sounds like the right kind of stuff. Like SREs and DevOps are kind of the same, right? So a lot of it's about like building, you know, scalable systems that are, you know, fault tolerant and have like high availability and you know, redundancy and all that stuff. That's my understanding of it anyway. And building tools around like automation and deploys and all that stuff. And security and monitoring, I think, are probably big parts of that as well. Always prefer API dev, data modeling, etc. Favorite things to work on. Yeah, I mean, you should definitely, you know, try to do a couple of LeetCode problems a day. You might find yourself warming up to algorithms. And then if you like warm up to it and you start to get the hang of it, you could look into a, you know, like you were saying, one of the types of roles where the interviews include a lot of data structures and algorithms. So I think I need 2 DP arrays. And I think I need 2 DP arrays because I think they're going to keep track of like the opposite sign because the differences have to alternate between positive and negative. Security Plus, yeah, that's another good one. Probably any of the like cloud certifications that you can get too. Like if you can get like the AWS like cloud certification, even if it's just the bottom level of it, and then the same for Google Cloud. Like all that stuff's gonna look really good on a resume. So how am I gonna do this? All of the DPs start at length 1. Let's call this like, unfortunately I feel like the best name is probably gonna be DP1 and DP2. I can't call one of them positive and the other one negative because even within that it's alternating. Wait, no it's not. I can call it positive and negative. I love AWS. Pos I, neg I. So positive I, let's try to do it this way. So positive I would be the length of the longest wiggle subsequence, ending at I with positive last difference. And then this would be with negative last difference. I think that'll work. And all of this still starts off at 1 because they point out that the first difference, maybe right, positive or negative, sequence with 1 element and a sequence with 2 non-equal elements are trivially wiggle sequences. So that's gonna work, I think. So what I want to do here is figure out the difference between, let's get the difference. Difference is going to be nums sub I minus nums sub j. Okay. And then let's do, yeah, here we go. So if the difference is greater than 0, we'll do something. Else if the difference is less than 0, we'll do something else. If the difference equals 0, we don't do anything because that doesn't count as a wiggle subsequence. Mr. John Droid, thank you for the follow. Appreciate that. Welcome to the chat. And welcome to the stream. Hope you're having a good evening or whatever time of day it is for you. So if the difference is greater than 0, then that means that we need to be looking at the neg array. But it's going to be pos. Okay, so I think this might work. So pos sub I equals the max of pos sub I and 1 plus neg sub j. I'm not entirely sure if that's right, but let's try it. And then this is going to be the opposite. So if the difference is less than 0, then we want to be updating yeah, we want to update the opposite way. So neg here, and pos here. AWS streams on Twitch sometimes. Oh, that's interesting. I didn't actually know that. What kind of content do they stream? And Billy said, I see, so it's just as you go through, if it isn't alternating, then it gets... Right, yeah, the opposite. Right, so if I look at because if I look at like an index I and an index j, and the difference is greater than 0, then we're forming a wiggle sequence with at least I and j, but then we also want to take into account everything from j onwards, which we've already calculated because we're iterating from the end of the array to the beginning. And then this is this, and then now the answer has to be updated from both of them. So the answer is the max answer in pos I, and also neg I. Semicolon here. Okay, good news is we passed example 1. Let's run, oh, there's 3 examples, so let's run all 3 examples. Oh, okay, so we're getting correct output for all 3 of the example test cases, which is POG. Whether or not that means the solution is accepted is unclear. I think n squared is going to be fast enough, so assuming my code is right, this should get accepted, but we should actually test on some other inputs here. Shell Gaming, not entirely sure, but mostly about scalability and different AWS services and how... Oh, okay, so it's like marketing. It's like, here's why our services are so good. Yeah, I can try to explain my code again. I'll use the visual tool to explain it if it gets accepted. Let's try to put something random in here. 3, 5, 3, 0, 7, 6, I don't know. Let's just put something really long. Let's get some bigger numbers in there as well. I'm literally just spamming random numbers on the keyboard. I just want to have a slightly more challenging test case, hopefully, for my code to handle. I don't know, bunch of 3s in a row right there. That's probably good enough. Let's run it on that. We can also run it on like trivial test cases, like 1, just 0 by itself, 1, 2, I don't know, 0, 0. I'm actually really bad at designing test cases, but hopefully if these are all right, the solution will be accepted. Oh, okay. This has to be less than 1,000. Let's make this 999. Okay, we're getting correct output. So apparently that crazy test case that I wrote was 34. And we're getting 34. So let's try this. I'm gonna submit. Hey, there it is. We got it accepted. Runtime is slow because there's a linear time solution to this, which we can spend a little bit of time thinking about. But before I do that, I'll explain my code. Test cases, forget to test as well. Yeah, especially stuff like this, like these 4. I'm trying my best to remember to always do like one element by itself and stuff like that. My code always gets stumped by those, unfortunately. We get it accepted though, and we also have a suggested next challenge. Null, yeah. This one, they promise you at least 1 number in the input, so I don't even think I could put empty array here. It wouldn't let me do it. Yeah, it says it's an invalid test case. So let me try to explain how this works. Well, so the most important thing to understand, I think, is what pos represents and what neg represents. So I wrote it out here. Hey Bill, thank you for the follow, really appreciate it. Putting my follower goal to 2 out of 5 for the day. Let's go. So this is DP. I actually have 2 DPs, but instead of calling them DP1 and DP2, I called them pos and neg. You could think of it as like DP pos and DP neg. And this is kind of like a sort of standard way to think about doing a dynamic programming where the ith element of the DP array represents the length of the longest wiggle sequence ending at I with positive previous difference, and then the opposite for neg. So let me try to do like a simple example. So let's say that the input is 1, 3, 1, 0. I don't know if that's good or not. So that's the input. We can call that like n equals. And so basically the way my code works is I start I at the end, and I have let's see, I have pause, which is going to be the same length. So it's an array with 4 things in it. And I have neg, same thing, like this. And so I initialize all these to be 1. So these all just start off being 1. And the reason they all start off being 1 is because that what's the word I'm looking for? That follows this description I gave here. So the element I of pause represents the longest wiggle sequence ending at I with a positive last difference. And so every single element of nums forms a wiggle sequence by itself. And that was part of the problem description. So if you just took the subsequence with just 1 in it, that's a wiggle sequence of size 1. Same thing for the subsequence just with 0 in it. That's a wiggle sequence just by itself. So that's why these all start off at 1. But then I starts off at the end and then moves this way. So we're gonna be updating these arrays from the end to the beginning, from the back to the front, is what I was trying to say there. So we actually can skip 0 because since let's see here. Oh, I have a typo in my code. That probably made it more confusing. This actually needs to be starting. Sorry about that. So pause I and neg I represent the length of the longest wiggle sequence starting at I. So that's why for this last number here in the array, 0, it just stays 1 because the longest wiggle sequence that starts at this last element, it just has length 1 and it's just 0 by itself, so it's 1. But then what we can do is we can move I over. Let's see. It's probably the easiest way to do that. And we move I here. So now we want to update the position. So if I put like a 0, 1, 2, 3 here, we're trying to update position 2 of pause and neg. So what we do is we start I here, and then we have j go from I plus 1 to the end of the array. And we take the difference of I and all of the j's. So the difference of 1 minus 0 is going to be 1, which is positive. So since it's positive, that means that we need to look at the negative dp, because the negative dp is going to represent the longest wiggle subsequence where the previous difference was negative. So since the current difference is positive, we need the previous difference to be negative. So it's going to look here and it's going to see that there's a 1 in negative. So it'll update, this number here will update to be a 2. Like that. So now what we know, after we finish calculating, I being at this position, we know that the length of the longest wiggle sequence starting at index 2 is 2, and that's because it's 1, 0. So then we go back again. So j is done. J iterated all the way through the end of the array. Now I goes here to this 3. And j will then be here, and then j will come here, and j will be here. But first j is here, so we do 3 minus 1. We get that this difference is 2. So since it's positive, we know that the 3 and the 1 form a wiggle subsequence of length 2. But if there's a negative subsequence starting at 1, then this just adds to that. So basically, we can look, so when j is at this position, we look at neg, and we see that the longest wiggle sequence, ending at, or starting at this position is of size 1. So we update this to be a 2. And then when j goes to this last slot, the difference is going to be positive again. And so we won't make a change. It still stays at 2. Hopefully that makes sense. I don't know if I'm explaining it very well. Let me delete all these. So then the last part of it is that I comes here. And so then I will come and look at all of the rest of the array. So I will compare to the 3, I will compare to the 1, I will compare to the 0. This difference is going to be 1 minus 3, which is negative 2. And so since this is a negative difference, we want to know the longest wiggle subsequence starting at 3, where the previous difference was positive. So we look at the positive array. And when we look at index 1, where the 3 is, we see that it's 2. So that's why this one will end up being a 3. And 3 here represents the 1 to the 3 to the 1, or it could represent the 1 to the 3 to the 0. Those are both valid wiggle subsequences. So that's the high-level idea. I don't know really how to explain it better. Like grind dynamic, do the LeetCode dynamic study plan. It starts off with like really easy ones, and before long you'll be able to build up, and like this will make a lot of sense. But whenever it comes to dynamic programming, best thing to do is just start off on easier problems. Like climbing stairs, for example, LeetCode climbing stairs. Stu Squared, you think you can make this a one-liner? That's nice. Like an easy to read one-liner or a jumbled mess one-liner? Because I would prefer something that I could read over a jumbled mess one-liner. Bill, you said, I get it. I get why not just long as they alternate neg pause, shift a counter. Let's see here. So you're saying that I could start at the end. Yeah, there might be I think that there's an n squared non-DP solution, and I think that's what you're talking about. So I implemented this as a n squared DP. Yeah, or the beginning. I think I understand what you're saying. An expressive literate one-liner. Nice. I mean, if you want to whip it up and throw us a paste bin, or even paste it in the chat, we can take a look at it. Yeah, Bill, I think that there is probably a way to do this without having to do DP in n squared time. There's also this follow-up that we haven't talked about yet. Apparently there's a linear time solution to this, which theoretically will eliminate the inner for loop. But for n squared, yeah, you could probably start at the beginning and go through the end of the array, keeping track of every time that the sign flips. Is that what you're saying, Bill? And then you can like take that, log whatever the max was that you found, then start at index 2. I'm pretty sure that would work. How do we make this linear though? That's what I want to know. There's a linear time solution to this. So let's see. What are we searching for in this inner for loop? So what we're searching for is the nearest so after I update pause and neg, can I just break? Will that make it faster? Because like after I find the first one, do I need to keep going all the way through the end of the array? I don't think I do. I think in this inner for loop, after I find the first like positive difference, and after I find the first negative difference, and I've updated posi and negi, I don't think I need to keep going and find more of them. Like, I think that's already going to be the best. I don't think that makes the solution linear, but I think it makes it faster. Let's just try to implement that real quick and see if we get a better runtime. So let's see. Let's have a bool. Bool update pos equals false. Bool update neg equals false. Here update pos equals true. Update neg equals true. And then if update pos and update neg break. So if this works, then I think we can figure out the linear time solution, because I think instead of like doing a for loop to search for these, there's probably a way that we could just store it in a lookup table. But let's just take a look here. Let's run it on this data. Okay, so those changes still pass all the test cases that I have. So let's submit. Ah, you see that? So just by doing this little optimization, we like increased our runtime significantly. Now we're faster than 63% of solutions. Let's see, what do you, example 2 shows 7, so you'll have to traverse the entire list, I believe. So what I'm thinking is that instead of, so in this outer for loop, what we're actually trying to find is the first start of a positive, like we're trying to find like the next start of a positive sequence, or the next start, and we're also trying to find the next start of a negative sequence. Now, if we can store those in a variable, then that improves the solution to linear time. So let's just create a variable. Int next pos equals n. Int next neg equals n. We don't need these anymore. Yeah, so this is just n minus 1. And then let's see, I think we can get rid of some of this. And so we want to do pause. Let's see if I can just write this. Oh, I also need wait, no, maybe this isn't right. Let's bring some of that back real quick. So for each index, I want to look up. So the thing is, if I look up next pos though, that doesn't mean that the difference between the current number and that number is negative, which it needs to be. Maybe this is the linear time solution because of this break. Like, we only iterate until we found the next thing that we need to find, which it's going to find it really quick. So we only have to, if you think about how many times this for loop runs, it only has to run until it finds a number with a positive difference and then a number with a negative difference. And then as soon as it finds that, which presumably in most cases, unless there's a bunch of like zeros in a row, it'll find that really quick. So I think this is good. I think this is linear time, or at least close to it, but let's look at the solution page and see what they say. Because I'm happy with this runtime, 63%. Dynamic programming. I really like the okay, it changed. You saw how that was just like hello world there for a second. So up, down, yeah, this is my code. This is the same solution that I had, which is n squared. And then approach 3, linear dynamic programming. Okay, let's take a look at this. Any elements in the array could correspond to only one of 3 possible states. Up position, meaning numsci greater than numsci minus 1. Down position, numsci less than numsci minus 1. Equal position, numsci equals numsci minus 1. The updates are done as, if numsci is greater than numsci, that means it wiggles up. The element, okay. At the end, we can find the larger out of those 2, right. Interesting. I don't know if I would have thought of this. Let's see if it decides to load the code. Okay, there it is. So it's the similar idea where they have up and down. In my code, I just call it positive and negative, pos and neg. Then up 0 and down 0 is 1. And then it goes through the rest of the array. Anytime it encounters an increase, okay. What's interesting to me is this solution only checks consecutive elements. Whereas I thought you had to compare like pairs of numbers, you know, like even if they're not next to each other. But apparently you can use this to just have to look at consecutive elements of the array, and that will tell you an answer. I kind of want to watch this video, but that sounds boring. Oh, it's okay. That's not very useful. Greedy approach. We do not necessarily need DP to solve this problem. It's equivalent to finding the number of alternating max and min peaks in the array. Nums1 minus nums0. So it iterates through the rest. It gets the difference between I and I minus 1. If it's greater than 0 and prevdiff is less, or if it's less than 0 and prevdiff is greater, then we increase the count. Man, that's so simple compared to what I did. Yeah, this is really cool. I think the thing that I'm still confused about is how you only have to look at consecutive numbers. Can you assign an operator to a variable? Yeah, I mean, you could use a function. Like instead of using like an infix operator, you could have a function reference, like, and you could pass in like a addition or a subtraction function. Or you could like a greater than or a less than function rather. Yeah, nested if else, that could probably go away. In my mind, the more interesting thing to get rid of is the inner loop, but yeah. Well, I think that's good enough for this one. This is interesting. I'm gonna have to think more about that, about this, like, only having to check consecutive numbers, because that, I'm a little confused, but I'll come back and think about that more. Let's see. What am I going to solve next? That's the real question. Perhaps longest common subsequence. Perhaps threesome. Given an integer array, return all triplets such that... Okay, yeah, I is not equal to j, I is not equal to k, j is not equal to k. So they're different numbers in the array, and they sum to 0. Okay, that's possible. What else? Making a large island. So I could solve this one, which would give us a break from DP for a moment. I think I'm going to solve this one next. Yeah, I'm definitely going to solve this one next, but before I do that, I'm going to take a quick restroom break. Everyone who's hanging out, thank you. Really appreciate it. Thank you for the follows that came in so far today as well. And yeah, I'll be right back in, you know, three or 4 minutes, and we'll solve this problem. Okay. I saw your comment, Bill. You struggle with math? Yeah. I think this will probably be a good one then. This one is gonna... So I looked at this earlier. I didn't look at the code, but I think that I can solve this with DFS. Gotta refill the tank. Just hold 1 second. Let me check a DM. Okay. So I don't think I'm gonna have to do matrix math for this. Like, this isn't gonna be matrix multiplication or anything. They didn't do a good job with the problem description because there's no drawing. But I'll make a drawing and kind of explain what I'm supposed to do. So you're given an n by n comparing and contrasting to grids. Yeah. So you're given the input binary matrix where 1 represents land, and 0 represents water. So let's say, as an example, we were given like a 4x4. This would be a good use case for using like some of the straight lines that this software lets me do. But anyway, so let's say that we have like 1, 1, 1, 0, 0, 0, 1, 1, 0. I don't know if this is a good example or not. For 1 here. Yeah, this is going to be an okay example. It's filling in some of my circles, my zeros, because it thinks they're supposed to be circles, which is kind of silly. I don't want it to do that, but it's done that anyway. So basically, connected groups of ones are islands. So we have 3 islands in this because they have to be connected 4 directionally. Diagonal doesn't count. So like these 2 ones right here don't form an island. So we have an island of size 3 in the top left. We have an island of size 2 right here. And we have an island of size 1 right here. And the question is asking, you're allowed to change a single 0 to be a 1. So in doing so, what's the size of the largest island after doing that? So what we could do is we could take this 0 and we could change it to be a 1. When we do that, the size of the largest island is now 5. But the problem is that's not as good as changing this 0 to be a 1. If we change this 0 to be a 1, we connect this island of size 2 with this island of size 3, and now we have an island of size 6. So the first thing I'm going to do is I'm going to DFS everything, and I'm going to assign each island a number. So I'm going to have another 4x4 grid. I'm not going to draw the lines, but basically we'll have something like we'll have like 0, 0, 0, meaning that all 3 of these are in the same island. We'll have a 1 here, and we'll have a 2, 2 here. And then everything else you can kind of think of as being -1. So make all the zeros -1s. And then any number in this new grid that's positive, or sorry, any number in this new grid that's non-negative means that that's an island, and because any like set of them that's the same is like islands that is like pieces of land that are an island together. Hopefully that makes sense. So this number 0 is basically an ID of island with ID 0, which is this top left island. This number 1 over here is island ID 1, and it's only got 1 piece of land in it. And then down here, this is island with ID 2, and it's got these 2 1s in it. So I'm going to write a DFS that basically goes from this first grid, which is the input grid, to this grid. And so I can do that with DFS. Yeah, I'm labeling the islands. Yeah, and so in graph theory speak, these could be thought of as components. So I'm basically going to label the components. But first I have to find the components. So to do that, I'm going to do a DFS. So int n equals grid.size. And let's make a new grid for the components. Vector of int components. So sorry, this needs to be vector of int components. We could call them islands, I guess, but they are components. N vector of int n, and we'll start everything off at -1. And then as we DFS, we're only going to update. We're only going to change from -1 to something else for like land. and we'll update it so that it's part of an island. Oh, I could do it in Python. Yeah, if that's more helpful for you. So yeah, so now islands equals, we have to do like a nested list comprehension. -1 for I in n. It doesn't actually matter. For underscore in n. And then we put all of that in a list comprehension for underscore in n. Is that right? So honestly, like my Python's more rusty than my C++, but I think that that would work for what I need. Oh, range. Okay, yeah, that's what we want it to look like. Okay, so now we need a DFS function. And I'll define it right here, def DFS. And DFS is going to take a I, a j, and an ID. So I and j is like the current coordinate that we're DFSing. And, oh, ID is a keyword. Let's call it a island ID. Like that. Yeah, I usually just use underscores for variables that I don't care what the value is. So I could do like ij here, right? But since I don't actually use I or j for anything, you can like make the code clearer, in my opinion, by doing underscores, because it makes it really clear to someone reading the code that we actually don't care at all what those numbers are. So, do we need a visited? We need visited as well. We also need dir I equals 0, 1, 0, 0, 1, -1, and dir j. Oh, this is probably call this. This is probably better. J dir. So, or yeah, even better. We'll just do it this way. I don't know. Dirs. There we go. Dirs. And then we want to go, what do we want to do? We want to go this way. So we need to go in all 4 directions. So we want to go this way, this way, this way, and this way. So I can iterate through these, and that'll take me in all 4 directions. And so I'm gonna implement DFS in a sec. First, I'll write this part. So for I in range n, for j in range n. So basically, we need to go through the whole grid and DFS. So DFS I, j, and let me think here. So we only want to DFS if we're looking at a new island right here. If this like part of it, if ij is forming a new island, we want to look at it. So the way we can check that is if grid. So first of all, grid ij needs to be a 1. And so I'm going to do something weird here, I think. Yeah, I'm going to do something weird here, which is as I'm finding the islands, I'm going to overwrite the original grid and delete the islands that I've already found. So what I'm going to do is I'm going to DFS, and as I'm DFSing for this first top left island, as I'm DFSing it, I'm going to update the numbers to be 0. And I'm essentially going to use that as like a Boolean visited grid, but I don't actually have to make one because I'll just do that. So I only actually need to check here if grid ij is 1. Then I can DFS grid ij and next island ID. So what we'll do is we'll have next island ID equals 0. I think this will work because I think after I find the components, I don't need the original grid anymore because the components will be fine. So next island ID plus equals 1. So this DFS right here will uncover an entire island. It'll set all of their island IDs to be whatever the next island ID is. And then I'll increase my island ID by 1. So the next time I start to DFS an island, it'll be a new ID. And I think that'll work. So now I can implement this. So this part is what I already said. So when I DFS a specific index ij, I update it to be 0. And I update my islands ij to be island ID. I think that'll work. And then I need to go through the DIRs. So for, let's just call it, these are bad variable names, iijj in DIRs. Then we want to DFS there if we can. So if ii, oh no, so ii is going to be, you know, the delta from this DIRs array. So then we want to get our next I is going to be I plus ii. Yeah, that's right. Next I equals I plus ii. Let me know if any of this part doesn't make sense. This is just going in all 4 directions. So next I and next j will be the next coordinate. Yeah, this is a depth first search. So Shal Gaming, brute force. So far, I don't think I've done anything like naive. Like I wouldn't consider this like a suboptimal, like naive solution. All I'm doing right now is I'm finding the islands, the components, and I'm doing it in a DFS, which is going to run in like linear time. So so far it's not suboptimal. I'm going to have to do more after I find the islands, and I'll have to try to make sure that that's not suboptimal. Warm Pepsi, yeah, this is depth first search, but welcome to the chat. Hope you're doing good. I mean, changing every 0 to 1. So I am going to go through all of the coordinates and try to change 0s to 1s. I am going to do that. So after I find the islands, I'll go through every coordinate and I'll try to see what happens by changing the 0 to a 1. And when I do that, I'll look in all 4 directions again. And basically I'll be able to like merge those sizes together of any like adjacent islands. And that'll tell me like what the size of the merged island is. But you do bring up a good point, which is I'm missing part of the implementation right now, which I'll have to go back and add, which is I need to keep track of the sizes too. So I'll have to add that. So, but first I need to check to make sure that we're in the bounds. So ni needs to be greater than or equal to 0, and ni needs to be less than n, and nj needs to be greater than or equal to 0, and nj less than n. Okay, and so after I check that, the last thing is to check to make sure that grid ni, nj is equal to 1. Then if it is, then we can DFS there. So DFS ni, nj and then the same island ID. And then after that code runs, let's print our islands and see if it works. Yeah, that looks right. What was my, I want to try to create this test case as well, because we can look at that test case. So, test case, example test cases. So it's going to be, okay, so what was it? 1101. 1000. 0100 and 0100 again. So let me save all that and let's look just at this one and let's see what we get. Yeah. So this looks right. Yeah. So my DFS worked. The problem is we don't know the size of the island. So what's the best way to do that? I have an idea of how to do it. Let's make another array and call it sizes. Does Python evaluate that Boolean from left to right? Yeah, exactly. Warm Pepsi, it does. So only if all 4 of these checks are true, will it run this last one? Yeah, that's a good question. I have an idea of how to do it. So we're going to have an array of sizes, and I would want this to be like 3s, right? These top 3 right here, I want to be 3s. These bottom ones are going to be 2s. Like, there's another way to do this using union find, but I think that for this problem, this will work fine as well. Yeah, so I need to keep track of the sizes. So here's my idea of how to do it. Current size. Oh, and this, do I have to put global grid here? I haven't written Python. Oh no, I don't, because the code that I just wrote like worked, so this should be fine. I'll have like a current size equals 0, and so here's what I'll do. Before I DFS here, I'll update the current size to be 0, and then what I can do here is current size plus equals 1, and then down here, as I'm unwinding from the DFS, I think I can do sizes ij equals, I'm not entirely sure if this is going to work, but we'll find out. Like that. How do I get it so it can see this variable? Seems like you have to somehow track the placement of the islands on the map as well. Yeah, so the idea is once I have this graph, once I have this grid, I can go through one at a time. Every time I find a -1, that means that it's a 0 in the original grid. And what I can do is I can look to the left, see that there's an island there. Warm Pepsi, good idea. Yeah, I'll do that. And I can look to the right, and I can like add the sizes together. So I should have made DFS an instance method, but that's okay. Oh, and this is... what do we get? Oh, it's not quite right. That needs to be a 3 right there. I'm kind of surprised that that didn't work. So we got 3, 2... 3. Oh, yeah, no, it's not going to work like this. I see why it's not working. So what I can do is basically keep track of all the coordinates that are in the island, and then after the DFS is done, I go through those. I don't really like that, but let's do it anyway. So since we're doing it that way, we don't need self. But that was a good suggestion though, thanks Warm Pepsi. I'll just do it that way. Could you list at every index? Yeah, that's what I'm going for. So I was explaining in this drawing that I'm updating every island so that I know like which island it's a part of. So this is like labeling the components. Yeah. And I do need to do that because it's possible for there to be a case where like you update a 0 to a 1, and if there's a 1 on either side of it, those could already be part of the same island, which is an interesting edge case that I should test. But yeah, that's the high level idea. So I just need to get all the chords of each island. So I'll do this. I don't need this anymore, and what I'll do is chords.push .append ij, and we don't need the island ID because we can just do that down there like that. And then what we can do is here for I don't know, Q and R in chords, islands QR equals island ID. Sorry, next island ID. And then sizes QR equals length of chords. Tell me that works. Yeah, now it's working. So you can see here we got 3301, which is correct. Oh, put on a different hat. Sorry, I missed that. Thanks for that redemption. I can put on a different hat. One sec. I was trying to think of interesting redemptions once I got the ability to do them in the channel. And so that's just like one of the random ideas I had. I do have more hats. I'm hoping to expand the collection of hats for this purpose now. So this is good now. So we have the island IDs and we have the sizes. So we have like everything that we need to actually get an answer. So the next part of it is to go through the whole grid again. I through N, J through N, and try to change, not actually change, but we'll be able to figure out what happens if we change a 0 to a 1. So we can just copy this. So it needs to be a 0 here. So the way we know it's a 0 is if islands ij, it needs to be -1. So if it's not equal to -1, we just continue. And then we'll have total equals 0. And we also need answer equals 0. And then down here we'll return answer. So total is 0. So now we can go through the directions again. So I can copy this code. I can actually copy all of this code. Let's see. So we got the bounds checking. We only care about it if islands ni and j is not equal to 0, or is not equal to -1. Is that right? Yeah. So here, yeah. So we wanna add to the total. So the naive way to do it would be total plus equals sizes of ni and j. But that's actually not correct because you could be surrounded on multiple sides by the same island. So we actually want to keep track of which islands we've done. So we can do like scene equals a set. And if, let's see, if islands ni and j, if that's in scene, we don't care. Continue. Is this right? Yeah, this is right. Otherwise, scene.add islands ni and j, and total plus equals sizes. I do have some more interesting hats too. I didn't put on an interesting hat this time. Not that many interesting hats though. I need to get more interesting hats. Oh, and then the last thing is, once we calculate the total for the, changing this 0 to be a 1, we update the answer. So answer is the max of answer and total. Oh, interesting. We got 5 and we should have got 6. Something's not quite right then. Let me just check. One of my favorite hats is my Noogler hat. I don't work at Google anymore, but I still proudly possess my Noogler hat, and I put it on every once in a while for the change hat redemption. Print, let's just check these again. Islands, print, sizes. So I'm pretty sure all of that was right, but I just want to check it again. 0, 0, -1, 1. Yep. That's correct. 0, all -1s, yep. -1, 2, 2, yeah, so pretty sure this is right. And then this is 3, 3, 3. Oh, I'm being dumb. Total equals 1. So total is 1 because we're turning a 0 into a 1. So it automatically, we're increasing the size of the cumulative island by 1. So that should work. Let's run this on all the test cases. Wrong answer. What happened there? 3, 4. Oh, we got a 0 for... Interesting. I'm glad I ran all the test cases. I'm getting a 0 for this test case, and it should not be 0. It should be 4. So for this test case, let's take a look at these values again. Oh, okay. So we just start off our answer as the max of the entire grid. Let's see, what's a clean way to do that in Python? Python max of 2D list. I want a nice oh, this looks nice. Let's use this. Yeah, I don't have NumPy, so I don't actually understand how this line of code works, but okay, that works. If anyone knows what this is about, let me know. So the max of sizes key max. So what does the key parameter do? Key parameter. Oh, I guess. Yeah, I mean, it's basically doing what we want it to do. It's taking the max of each row and then finding the max of those. That makes sense. Okay, so that solves that bug. We'll run it on these again. 3, 4, 4, 6. An interesting test case is, like, for example, if I were to change this to be a 1 and this to be a 1, that's an interesting case because now this 0 is surrounded by the same island on 3 sides. So I can update that test case to do that, and we can try that as well. Although I'm pretty sure it's going to work. So what was it? We put a 1 here and a 1 here. Yeah, and that still works. And now the answer is 9 because we get a big island. Okay, I think that's how to do that one. Well, I haven't submitted it yet. Okay, let's just go for it. Should I test more edge cases? Let's see, what else could... I mean, we could test something like that. Those are good test cases. Let's check those as well. Ooh, nice. Oh, you know what? I was expecting to see 0 for this test case where it's just a 0, but that's not right because you flip it to a 1 and you get an island of size 1. So my code handles that, which is great. All right, let's submit. Nice. There it is. Pretty quick compared to other Python 3 submissions. 4,000 milliseconds. Nice. Okay, well, that's how to do that one. Well, I wonder what these suggested challenges are. Let me close some of this stuff. What is equal tree partition? Sounds annoying. Earliest moment when everyone becomes friends sounds interesting. I wonder what that's about. If anyone has any fun problems that they want me to look at, I'll take suggestions. I'm probably gonna do like one, maybe two more problems. Hold on, let me just check a DM real quick. That's my problem. These more complex problems make me sleepy. Yeah, what is this? Equal tree partition. Given the root of a binary tree, return true if you can partition the tree into two trees with equal sums of values after removing one edge. Yeah, this sounds like one of those ones where the first thing you do is you store the sum of each subtree in each node. And then it's easy to calculate what will happen by removing each edge. Like if you remove this edge right here, then you can subtract the total sum of this subtree from this to get the subtree of that, and then you already know that. So that doesn't actually sound too bad. Have I done this one before? No, I haven't. I should probably do that one. And have I done this one before? No. What is this one about? There are n people in a social group labeled from 0 to n minus 1. You were given an array logs, where logs I is timestamp and xy indicates that x and y will be friends. Oh, this one right here is definitely union find. Because you can just sort by the timestamps and then go through them, you know, by timestamp ascending, and then merge sets at each time, and then as soon as you have one big set, then that's your answer. So that one's union find. I do know how to code union find off the top of my head. It's just not, I don't know, I don't really enjoy coding it up, but let's do equal tree partition. Because I haven't done much binary tree stuff recently, so this will be a good practice. So I just want to basically DFS the tree, the binary tree, and store the sums of each subtree in the node. So let's make another function def calc sums self node, and then here the first thing I'll do is I'll just do and then we want to find the sums of everything on the left, the sums of everything on the right, and then store that on the current node. So I think we can do like calc sums Oh. Node dot right. Yeah, let's do it this way instead. Let's have it return 0. And then some here we'll do like this sum, great variable name. This sum equals node dot val. Then this sum plus equals that. This sum plus equals that. And then I'm just gonna do this. I think this will be fine. Node dot sum equals this sum. And then return this sum. And then what we can do is print root dot sum, and we can see if that worked. 30. 30 is right. Okay, so that code probably works. So I've gone through the entire binary tree, and I've stored the sum of each subtree on the node as root.sum. So then the next thing to do is to, I think we DFS again, but for each edge we try to remove it. So answer, oh, we just want to return true if we can partition into two trees with equal sums. So I'll just make a function called DFS here. And then if DFS root, or no, I can just, yeah, we can just do it this way. Return DFS root. So this DFS will return true if it's able to sever one of the edges between itself and one of its children and have the sums be equal. So we just have to try two things. We have to try to sever the left child and see what we get, what that does, and we have to try to sever the right child. So sever left edge, and then sever right edge. So to sever the left edge, so conceptually, one-liner. Oh, for that other problem, or for this. Ah, hold on. Let's take a look at that in a sec. Let me just finish this. This one, equal tree partition. So if node dot left, we'll try to sever the left edge. So if we try to sever the left, then we want to check to see if return true. Yeah. Oh, yeah. We can do it this way. This will work. So how do we calculate? So let's say that we sever this edge right here from between the 5 and the 10. Then left sum equals node dot sum. Left sum is just node dot left dot sum, and then the rest is going to be equal to node.sum minus left sum. And then if left sum equals rest, return true. And we can do the same thing for the right. Oh, don't worry. I'm getting too tired too. I think this is my last problem, but this one right here I like. I'm going to solve it on Tuesday. So anyone who's interested in this information, I'm going to come back and do another stream like this on Tuesday. So, because I'm not going to be available tomorrow. So I'll be back for more of this on Tuesday, and yeah, it'll be great. I'm also going to start the stream with Clash of Code too. Okay, now, if we don't return true by severing the left or the right edge, we have to try to sever any of the edges in the left and the right subtrees. So what I can do is if DFS node.left return true, and then if DFS node.right return true, and then if we try all that and nothing works, return false. Colon there. Okay, so this might be good. Let's run it on both of the examples. Submit. Oh fuck. Yeah, I didn't bother to create more test cases because it's always annoying to make test cases for binary trees on LeetCode. So, hold on a sec. Okay, so looking at this this test case, it's 1 null. That means null as the left child, I think. So then it's 1, 2. I think that means this. Is that what that test case means? So in this case, it should be false, right? There's no way to do it. My code is saying true? Yeah, my code is saying true. Where's the true coming from? Well, we can figure it out easily using the debugger. Okay. So those are not equal. So we DFS to the right. Okay, step into. Wait, why is node 2, 2? Okay, well, in this case, it has a, so it's going to have a left child, so it should come in here. Oh, it needs to know the parent sum as well. So when I sever this, it's actually the sum from the root minus that. Yeah. We need to know the total sum. We just pass it in. So when we DFS here, we pass in the total sum, which is going to be root.sum. Total sum. And then when we sever the edge, it's total sum minus right here. And then we pass in total sum. That's an annoying reason to fail. Okay. We'll try it again on all the test cases. That looks good. There we go. That was a stupid bug. But we got it. We got that one right. Just like that. Pretty fast in Python, faster than 91.6, so that's good. It's using a lot of memory, and I assume that the reason, I assume that you can probably solve this problem without having to store the sums. Like you could probably DFS and do all this calculation like as you go. So that's fine. Okay, let's take a look at the one-liner. What did you say about it? Too tired to make it general enough not to have to handle the edge cases separately, but the idea behind my saying it could be a one-line is that you really just need a sliding pass to look for any direction changes. So define a wiggle max length. Okay, so you get the deltas. Use zip nums.tail. Oh, okay. So that tail is just everything but the first one. So, and then you map it to minus. Right, so deltas is going to give you the difference at each step. And then the changes equals deltas dot filter not 0. And map it to underscore dot sign. Okay. So if changes is empty, return 1. Else 2 plus changes dot sliding 2 dot count. Now you know Python way better than I do. I don't even know what sliding does. And then counts. Oh wait, this is Scala. Sorry, I'm tired. I thought this was Python for a second. Which explains why I don't recognize much of what's going on here. But yeah, so basically changes just the positive and negative sign. Right. I understand. Because you filter out the zeros and then you map it to the sign, which is cool. Sliding looks at adjacent elements. So you're creating a sliding window of size 2, and you're sliding across. And then you're counting array left, right, left equals negative right. Right, where you're, left and right are the sides. So it has to be 2 plus, yeah, that makes sense. Oh, that's cool. Can I run this? Oh, nice. I'm not familiar with this this website. Oh, this is a Scala specific thing. Gotcha. Cool. All right, thanks for showing us that. That's a nifty solution to the problem. I'm assuming it runs pretty fast as well. Let me run it in LeetCode. So can I? Yep, Scala. I already got it accepted. So I don't mind just pasting your solution in here. I wanted to see how fast it is. Missing parameter type for expanded function. What did I miss? Oh. Yeah, unfortunately it's not letting me run it. Otherwise I would. I'm getting a some sort of compiler error, or maybe a runtime error. Oh, I see. Let me copy that. Like this. All right, so let's submit. Match error. Well, I mean, I assume that you didn't run it within LeetCode, otherwise you would have had that. But that's dope though. That's a cool solution. But yeah, so I think that's gonna be it for me for tonight. Everyone who was here, thanks for hopping in. Hopefully it was fun, relaxing, educational. Whatever you got out of it, I'm glad you were here. So yeah, I'm gonna call it for the night. That was my last problem. Thanks for the follows. 2 follows came in. Oh, and a 3rd follow just came in. Thank you, Stu. Appreciate that. John Droid, Bill DeGray, and Stu Squared. Thank you all for following. Like I said, I won't be here tomorrow, but I'm going to be back on Monday. Usually I start off the stream with Clash of Code, and you know, we can clash together. If you haven't played Clash of Code, it's fun. It's like little mini, like 10-minute coding contests with simpler problems than what LeetCode has. And then I usually do that for a while at the beginning of the stream and then switch over to LeetCode later. And yeah, so that'll be happening on Tuesday for anyone who's interested. But other than that, yeah, I'm gonna go. Oh, thanks, Bill. Yeah, I hope I get the call back as well. It could happen on Monday, but they said that sometimes the things can get delayed, so it could be Tuesday or Wednesday, but it should be sometime this coming week. So fingers crossed for good news, and I'll definitely, you know, let the chat know on stream when I hear back. Either way. Okay. Yeah, I'm tired. I gotta go to bed. Thanks for everyone who was here. Really appreciate you, and have a good night. Peace.